Good everyone. Welcome to Module 6 of the Networking Essentials course. Today we'll be dealing with the design and the access layer. Alright, so we're looking at encapsulation and the Ethernet frame, the hierarchical network design, the access layer, and the broadcast containment. So let's look at encapsulation and the Ethernet frame. Alright, so encapsulation is just more like sending a message when it comes to computer systems. Just like when you have you want to send a letter to someone, like put it inside an envelope. So putting the letter inside an envelope is encapsulating the message. So you're putting the letter into the envelope is encapsulation itself. All right. So but in the communication for on an IP network, all right, there is a format, okay, which the message is being um programmed to take. All right, so it's contained in bytes, right? And these bytes or these frames actually, right, have specific bytes assigned to some certain part of the message, right? And this frame contains the destination IP address, the source IP address, the version, the traffic class, the flow label, next header, and some other information that is only understandable by the receiver on the network. So the Ethernet frame now is you can group it under the layer 2 um, protocol data unit. Alright, so PDU is protocol data unit. Remember when we use packet tracer to send a sample message, that is a PDU. Alright, so this Ethernet frame field consists of the preamble, right, the destination MAC address, source MAC address, type length, data, and FCS. All right. So now let's look at the hierarchical network design. So in designing a network, all right, there are two things to consider: the physical design and the logical design. All right. So there's a physical address, which is a MAC address, and there is a logical address, the IP address. So the MAC address is an address that you cannot change. More like your as a human being now, your MAC address is your fingerprint. You can't change your fingerprint. You can't change your biometrics. All right. Your biometrics is a constant factor. So when a network interface card, an NIC, is being created, a network address is being embedded on it. So that network address cannot be changed. So that network address is what is going to be used to identify that particular network interface card on the network. Then the IP address is what is given to the um, NIC when it's connected to a network. Just like, for example, you're a student. When you enter into a school, you'll be given a MAC number. So that IP address is just like the MAC number, depending on the school that you're on, depending on the network you're on, you'll be given an assigned an IP address. So an IP address can change over time. So there's a lab for this. You would need to go through that. So network addressing is done in hierarchical fashion. So we have North America, Canada, Nova, and Halifax. So these are different, could be different areas for a network. So different IP addresses will be assigned to different network interface cards that are connected to the network around America, North America. When it comes to Canada, a different IP address. When it comes to Nova, a different IP address. And when it comes to Halifax, a different IP address. So there are benefits of this hierarchical design. One is increased efficiency, optimization of function, increased speed, and a way in which to scale the network without impacting the performance of existing ones. So there are three layers. There's the access layer, the distribution layer, and the core layer. So the access layer provides connection to hosts on the local Ethernet network. So this is where the host machines are connected to each other, connected to a particular switch. And the distribution layer, right, is what interconnects the smaller networks to each other. Right, and the core layer provides a high-speed connection between distribution layer services. So the core layer is connected to the distribution layer is connected to the access layer, which is what connects to the host devices. So an example of the access layer is a switch. All right, so here is a picture of a Cisco um, M2600X access layer. Then another example of the distribution layer is a Cisco C9300 series switches, right, and the Cisco Catalyst 9600 switch. All right, let's look at the access layer. So access layer devices provide access to, so a host can join a wired or wireless network. All right, so in a wired network, each host connects to an access layer network device, which is a switch. Then we also have Ethernet hubs. So Ethernet hubs are also a way to provide a way that hosts are connected to each other or connected to a network. All right. So for a hub now, only one message can be sent through the Ethernet hub at a time. And hub takes signals from one port and sends the message out all of the other ports. So when you send in a hub, when you send a message from this guy, when you want to send to this guy, by the time it goes to the hub, the message is being sent to everybody. So it's not dedicated to this particular destination. So a hub, in that means, in that case, a hub is not a smart device, right? Because it does not know how to identify different hosts on its network. Then we also have Ethernet switches. All right, so Ethernet switches are smart devices. All right, so it builds a MAC address table so that it can identify each host on its network. All right, so the switch uses the MAC address table to send the message to a specific port. All right, so this is an example of a MAC address table. So when this is sent to this, so the switch identifies every host connected to it at the moment and now know the particular host that the message is supposed to go to. So the MAC address table is being built by examining a frame as it comes to the switch. So a switch has the source MAC address of the device connected to the port which the frame came on. So the switch then forwards the frame out to a specific port when the destination MAC address is in the MAC address table. So a switch forwards the frame out to all hosts, okay, except the sending host when the destination MAC address is not in the MAC address table. So when, as long as all these devices are connected to this particular switch, so when this source now sends a message to this particular destination, the message comes to the switch first. So the switch now detects every MAC address that is connected to it apart from this particular one, and now know or find out the particular destination that this message that was going to be sent from here is going, and now forwards the message to this particular switch. So let's look at the broadcast containment. So a broadcast message is used to contact every other device on the local network. So when you send a broadcast, all right, let me say from here, all right, when you send a broadcast to this switch, so the switch sends that particular message to every other device on the network. So when you send the message from here, it goes to every other host and goes to the other switch here. So an Ethernet broadcast is all um ones in the destination MAC address, right? So this is FFFF. So now here it says I'm new here and I want everyone to know my name. I will send a broadcast to announce myself. So whenever a new host joins the switch, it sends a broadcast to announce that, hey everybody, I am here. All right, so when the message has come here, so everybody on this particular switch knows that this new host is here. So the switch also sends the message to the next switch and notifies everybody on this host here, right? So that they can know that what a new host has joined the network. So now there's something called broadcast domain. So broadcast domain is the area through which a broadcast message can travel. So each local Ethernet network is a broadcast domain. So routers are used to divide the network into multiple broadcast domains. So a router, that's mostly even what makes a router smart, because a router can be regarded as a broadcast domain. So every port on a router is a broadcast domain, such that whenever a message is being sent to the router, it can what broadcast or announce that particular, or when a host is connected to the router, it can announce that particular host to every other port that is on its switch rather. So when a new host joins the switch announces the MAC address of the host to every other host on that is connected to it on the network. Now let's look at the access layer communication. So in order to send information from a device that is on an internet network, the device must supply its own source MAC address, a destination MAC address, its own source IP address, as well as what the destination IP address. So the address resolution protocol, which is the ARP, is used to discover the MAC address of a device on the same local network. So it's the ARP that helps to what detect the MAC address of every other system on the network. So the ARP uses three steps to discover and store MAC address of a host on the local network when only the IPv4 address of that host is known. So these are the steps now. The sending host creates and sends a frame address to a broadcast MAC address. So contained in the frame. So contained in the frame is a message with the IPv4 address of the intended destination host. So each host on the network receives the broadcast frame and compares the IPv4 address contained in the message with its own IPv4 address. So the host with the matching IPv4 address sends its own MAC address back to the original sending host. Now the sending host receives that message and stores the MAC address and the IPv4 address in an access resolution table, in an ARP table, right? That's exactly what I was explaining since. Now look at here, this example says I must send out an ARP request to learn the MAC addresses of the host with the IP address of what? 192.168.1.7. And where is 192.168.1.7? This is where 192.168.1.7 is. So when it has fully learned, this switch now have learned that this one has the IP address and the MAC address of that this message was being intended to send. When next this system here is sending a message to the system, the switch will no longer announce, right? Because the switch has already learned that this particular system here has that particular MAC address and the particular IP address. Okay, let's look at network design and summary. So we've learned about encapsulation, all right, which is placing a message inside a particular format. I've looked at a part of encapsulation process on the internet network is to create a frame that includes the source and destination MAC address. All right, so and we also understood that networks have a hierarchical design of IP addressing that includes a network portion and a host portion. So networks can be designed using a hierarchical design model with three layers: access, distribution, and core. And the access layer um, device provides connection so that hosts can get onto the network. The distribution layer connects network. The core layer provides a high-speed connection between distribution layer devices. So hubs take signal from one part and sends the same message out to all other ports, whereas a switch is an intelligent device that builds a MAC address table by examining and saving the source MAC address from a received frame. Then we also learned that switches build transmit messages based on the destination MAC address and comparing it to the address found on the MAC address table. And if destination MAC address is not on the MAC address table, flooding is used to forward the message out all ports except the port that is what's sending the host attached. All right. So then an access resolution protocol is used to send a broadcast message of all ones to discover the MAC address of a particular host. So routers divide the network into multiple broadcast domains. So a broadcast can only be received on a local network. Then you also need to take note of these different words: encapsulation, frame, Ethernet frame, physical address, and the rest. All right. Module 7: routing between networks. So we understand the need of routing, the routing table, and we'll create a line. So why is routing needed? Now, routing criteria for dividing a local network is what? Broadcast containment and security. All right. So routers in the distribution layer can limit broadcast to the network, to the local network where they need to be heard. Although broadcasts are necessary, too many hosts connected on the same local network can generate excessive broadcast traffic and slow down the network. So you can see here that this router has um, is what is connecting this particular switch to this other switch. So when you want to connect multiple networks, for example, this is on first floor, this network is on the second floor. So because we want to be able to send the broadcast to all of them at once, we connect the first floor and the second floor to a particular switch in the server room and connect it to the router, okay, that is making all of them probably connecting another building to the same network. So when a broadcast is sent, right, all these hosts here will receive the broadcast, and that can slow down the network. Okay, so depending on the media that you're using to transmit information, all right, that would in affect the speed at which messages are being received. Then another reason for dividing network is for security. So routers in the distribution layer can separate and protect certain groups of computers where confidential information resides. So routers can also hide the addresses of internal computers from the outside world to help prevent attacks and control who can get into or out of the local network. So that is very, very self-explanatory. So this router now, okay, separates this particular host here from the network outside the router. All right, so which means that if there was another router connected to this, that router can now um, connect other devices externally to the network, but separating these other internal devices that are within the company, okay, from um, being able to be accessed by people who are outside the company. So there are some criteria for dividing local network. There's location, all right. We've looked at broadcast containment, look at security. We also have locations and logical grouping. Now, when different networks, when different a company has different buildings, all right, routers in the distribution layer can be used to interconnect local networks to specific locations of an organization that are geographically separated. Just like what I was explaining before, when we wanted to connect to wanted to connect the public to your network. So now in this case, you're connecting two different buildings to the same network. So what connects the buildings are the routers, not the switches. All right, because if it were to be the switches, it will be wired. And imagine running an Ethernet cable from one building, and your building is at a point A, a location A. You now run a cable via all the NEPA poles that are leading to the point B. So instead, routers can do that with wirelessly. Another way is for logical grouping. So routers in the distribution layer can be used to logically group users, such as departments within a company who have common needs or for access to resources. Now, we can separate, let's say in a building we have different floors. We can separate the first floor, second floor, third floor with routers. Okay, so just so that everybody on the first floor will have access to the same resources. Probably you're grouping them by levels, all right? So people with level one will have only level one privileges, people with level two will have only level two privileges, and so on. So now, we actually need routing because it's very, very important. So this is where we'll start looking at IP address, all right? So in the IP address is divided into two portions, all right? The network portion and the host portion. That's why when you see subnet mask, you now see 255.255.255. So the subnet mask helps to determine or tell you what the network portion of the IP address is, and what the host portion of the IP address is. So let's look at the routing table. Okay, now the routing table helps for path selection. So each router interface connects to a different network. So a routing table contains information for how to reach local and remote networks. So the IP address or the destination IP address is used and compared with the network in the routing table to determine the interface to forward the packet out of. So imagine several routers are connected to each other, right? When you want to send a message from a building A, company location at point A or location A to, let me say, Access Bank wants to send a message from one branch to another branch, all right? That message is being sent to the router. So it's the router that now finds out the particular branch that that message is going to go to using the routing table. So routers do not forward broadcast messages. It's important to take note of that. So packet forwarding. Now, the destination MAC address is used to forward the packet to either the router if the destination IP address is for a different network or a specific network device on the local network. So the ARP table shows a mapping of IP address to MAC address. Remember, the ARP is the address resolution protocol. All right, here you see that the host on a network is on a network directly connected on one of my other interface. I will check my ARP table. There it is. Now I can forward the packet. So you can see, let's assume we're going to send a message from H1 to H6. So H6 is connected to another port on this particular router. So the message comes from the switch. Okay, since the switch already knows that this is not the particular IP address or MAC address that the message is for, it's going to forward it to the router, and the router now checks its own interfaces, all right, of the switch is connected to it. So now find out, okay, the person that the message is meant for is on this particular network or on this particular network. Now you can see here, now there are different networks. This one is 192.168.1. That is the network. This other guy is here, what, 192.168.43. This is a different network. 192.168.2. This is a different network. So when message is being sent from this switch now, okay, because the switch understands that the message is meant for a host on a different network, it sends the message to what, forwards the packet to the router, and the router now intelligently what, checks the network and send the message to the particular network that that IP address what has. So a routing table contains network addresses and the best paths to reach a network. Two two-way routes can be added to a routing table. I'm going to explain that later. Now, so you can dynamically learn from other routers and manually enter, and they can be manually entered by a network administrator. Just like when you want to set up IP addressing, all right, you can use static or dynamic. Static is when you manually enter the IP address, then dynamic is when the IP address is automatically assigned. So a default route is a router interface used when forwarding packets to a destination that is not in the routing table. So if a packet is destined for a network that is not in the routing table and no default route exists, the packet will be what dropped. The message will not be sent. Now, you need to know what a default gateway is, alright? So when a host sends a message to a device on the same network, it forwards the message directly to and use the access resolution protocol to discover the MAC address. When a host sends a message to a device on a remote network, okay, the host uses the MAC address of the router. Oops. The host using the MAC address on the router as the destination, but still has the IP address of the remote host as the layer 3 destination. It is very important that each host has the correct default gateway that is the IP address of the router on the same network. So you can see here that H1 has a default gateway of what 192.168.254, which is what the IP address of the router. H2, right, will have the same default gateway because it was as the IP. So it means that whenever this wants to send message to any IP address on this network, all right, it will send it to what through the router. So LANs are under one administrative control. LANs are usually either wired Ethernet or wireless. So you can use a wireless router to create a LAN, or you can use different network cables to create a local area network. Now, let's look at the advantages of a single local segment. Appropriate, it's appropriate for simpler network, so there's less complexity and lower network cost, and it allows devices to be seen by other devices and faster data transfer, okay, and ease of device access. The disadvantage is that all hosts are in one broadcast domain, which causes more traffic on the segment and may slow network performance. So it's harder to implement query of service, it's harder to implement security. So now you can see there's no router in between. So this is what a single local segment. So advantages of having hosts on a remote segment. Now you can see now the router has come into the picture. So it is more appropriate for larger and more complex networks, splits up broadcast domains and decreases traffic, can improve performance on each segment, makes the machines invisible to those on other local network segments, and can provide increased security and can improve network organization. So the disadvantages are it requires the use of routing, which is the distribution layer, and routers can slow traffic between segments. So more complexity and expense. So it requires a router. You need to get a router. So which means that the traffic, when you want to send a message from here, it might send slower than when you want to send a message from H1 to H5. So when H1 is sending a message to H6, H7, or H8, or H9, or H10, the time that the message will use to get from H1 to H8 will differ from the time that the message will differ from the time that the message will be sent from H1 to what H4 or H5. All right, so there is a lab concerning this one, so you should go through it to see how we can observe how data flows in a local area network and how data flows in a wireless router. All right, so we've looked at a lot of things. We looked at why routers are needed, the importance of routing, of routers for security, for network segmentation, and see how the routing table works. You see how we understood how a network is message is being sent from one branch to another. Probably if they're on the access bank wants to send the message from one branch to another branch. Okay, that is possible because they are the network the message is going to be routed from that particular branch to another branch. So there's a router in between the network. Then we also understood what broadcast domains are: physical grouping, last routing table, path selection, default gateway, default route, local area network, local network, and remote network.